The other topic for week number 1 is strings, so we should go and ask our new friend ChatGPT for some exercises on strings. Before I do that, I'm going to add my include statement for string to all of my template files. And then we'll go over and say, I'm learning C++, that is C++ 20. Can you generate, I better say what I know. I already know about strings, vectors, and basic input and output. Can you generate 3 programming exercises involving strings? Don't show me the solution. And we'll see what it comes up with. Of course, here are 3 programming exercises involving strings. So, exercise 1, string reversal. Write a program that takes a string as input and outputs the reverse of that string. I think that's a nice exercise to ease into strings. For example, if the input is hello, the output should be, and this is the reversal of hello. Exercise 2, palindrome check. Create a program that checks if a given string is a palindrome or not. A palindrome is a word, phrase, or sequence of characters that reads the same backward as forward. Ignore spaces and punctuation during the check. For example, race car and this phrase, a man, a plan, a canal, Panama, are palindromes. So I'm actually noticing here that it doesn't say it, but it seems to want me also to ignore uppercase letters. I don't see it saying that anywhere. So this uppercase A and this uppercase P don't match up to the lowercase a at one end of the thing and the lowercase p at the other. So it seems like if it thinks this is a palindrome, it must mean that I should ignore uppercase. I should assume all letters are lowercase or something. I'm going to ask it for a clarification when we get to exercise 2. Exercise 3, build a program that takes a paragraph of text as input and then counts the occurrences of each word. Oh, that's a nice one. We're probably going to need both vectors and strings to do exercise 3. Output a list of unique words along with their respective counts. Treat uppercase and lowercase letters as equivalent. That is to say, this is case insensitive. Disregard punctuation and consider words separated by spaces. Okay, there's a lot to unpack with exercise 3, but we'll get started with exercise 1. So write a program that takes a string as input. I'm actually going to ask it to clarify something about that for me, but first I'm going to head over here. I'm just going to paste this in. So the thing I want to clarify is the user expected to enter one word, or are they expected to enter a bunch of words? Like if I enter a whole line of text, does that count as the string that I take as input, or am I only working with the first word? I'm going to do the exercise first and come back to that. Okay, I'm just going to make sure that my template compiles and my compiler works. All right, so what I'm going to do is first take a string as input. So I'm going to say std string. We'll call it input string. Actually, I'll just call it input. It's pretty obvious that it's a string. Then I'll ask the user, enter a string. And then I'll just prompt them to enter it on the same line, and then I will do cin, and I'll read from that into my string input. We could argue that I should do a check on this to make sure that they do enter something, but I'm going to take the position that the only situation where string input fails is when the input ends. That is, the user just stops providing input. And in that case, we'll treat the string as being empty. So I don't see the need for any further error checking there. So this form of input, using stdcin and the stream extraction operator, this will result in me reading only one word. If they enter multiple words, it will not read all of them. And I'll come back to that issue in a minute. So I'm just going to say first, okay, I'll print out the input string. And then let's see. I'm going to put the string in square brackets so we can see all of the characters inside of it. So even if we have spaces or something, that we can see that they're there. And then I'm going to compute the reversal. So to compute the reversal, and I like doing string reversal because it's a good way of emphasizing this. I actually believe I did do the reversal of strings in some other video, but we'll just do it again. Basically, I want to take advantage of a property of the plus operator on strings. So what I'm going to do is I'm going to start with my input string. There it is there. I'm going to build up a new string from scratch. And at each step, I'm going to modify that new string by pasting together 2 pieces. So what I'm going to do is I'm going to walk from left to right on my original original string. I'm going to take the character that I see in my original string, and I'm going to attach it to my new string. And the way this is going to work is, at each step, I'm going to take the current value of my new string, and I'm going to attach the next character to it on the left. So currently my new string is empty, so I attach H, well, I'll put it over here. H gets attached to it on the left. Then I go to the letter E in my original string, and I attach E to H on the left. And then I get to my L, I attach L to EH on the left. And hopefully you can see what I'm building to here. If I keep doing that, I will get the reversal of the string. And unlike in C, where string reversal in C is a little bit more complicated, it requires a little bit more bookkeeping, in C++, I think it's actually quite a pleasant exercise. So here's how I'll do that. I'll make a new string for the reversal, std string reversed, and then I'll iterate through every character in my original string. So I'll use a for each loop. So for each character C in my original string input, I'm going to attach the new character to my reversed string on the left. So I'll say reversed equals C plus reversed. So there's the old value of reversed, and there's C being attached to it on the left. And then I'll print that out. So I'll steal this print statement here. Okay, so reversed string. And then I print out reversed. And I probably should have tested that before I wrote this part, but it's short enough that I'm willing to take that risk. Okay, practice strings 1. Enter a string. I'm going to enter the word hello, and there it is. It looks like it got reversed. I'm going to enter the word world. It looks like it got reversed. Now I'm going to try entering 2 words. And we can see that there's a bit of a problem. So this input mechanism reads 1 word from the user. I guess I want to be able to read an entire phrase. Now I'm going to ask ChatGPT to decide. For exercise 1, is the string entered by the user allowed to contain spaces? I'm going to have to tell it, don't show me the solution. Yes. For exercise 1, the string entered by the user can contain spaces. So I'm going to do that. There is a way of reading input that contains spaces. I guess I want to read an entire line of text. And so what I'll do for that is I will use the function std getLine. So getLine takes a place to read the line from. So it'll be cin, and a string into which the line is read. Now, in the video where I talk about getLine, I observe that there's something strangely creepy about the getLine function if you're coming out of a C background, which is, how is it able to take this string as a parameter and then, not as a pointer, just as a regular parameter, and modify it? But go look at the lecture videos if you want an answer to that question. For now, I will just use it. Enter a string. Okay, I'll enter hello world. Okay, that works. Let's make sure I can reverse short strings, that nothing breaks. Okay, that's good. Let's see what happens if I enter strings that contain lots of repeated characters. I don't expect too much trouble there, but it looks like that works as well. I think I can say that the exercise is complete. Now, you might look at this and say, wow, that just came out of nowhere. How am I supposed to know to use the getLine function? Okay, 2 answers. In this course, on an exam or something, in general, you'll be told in advance what you need to know and not know, and you can bring a piece of paper into the exam with you, so you can bring in notes. With obscure library functions, usually you're told use this library function. You might be expected to know how to use it, but you wouldn't be expected to have that whole list memorized. Suppose you wanted to read a line of text and not a word, but you didn't remember how to do that. You could ask ChatGPT to help you. You could say, how can I read an entire line from the user in C++? And we'll see what it comes up with. It should give me some code. It's going to actually suggest using getLine. There are other ways of doing it, but getLine certainly is a pretty common method. You could use getLine. This allows you to read a line of text including spaces until a new line character is encountered. And we can see here, there's a basic example, some code ChatGPT wrote for us that uses getLine, which, as far as I can tell, is correct. Okay, so I already did that, though, and I think I've now completed exercise number 1. So I'm going to move on to exercise number 2. However, I am almost certain that I'm going to want to steal a bit of my exercise 1 code for exercise 2. I guess I need a compile command for exercise 2. There we go. We'll head over to ChatGPT. We'll go grab exercise 2 from earlier. So exercise 2 has an ambiguity, which is I'm going to ask it, in exercise 2, you said that this sentence is a palindrome. I found that with ChatGPT, if you want to argue with it, it's good to just give it back its own phrases and say, you said this, what do you mean by this? Is a palindrome. Does that mean that I should ignore capitalization when I solve the exercise? I guess I have to say, don't show me the solution. And then we'll change this. Yes, you should ignore capitalization, treat uppercase and lowercase letters as equivalent. This means that this phrase here should be considered a palindrome. All right, so I'm going to actually, because I'm going to want to test this eventually on a bunch of palindromes, obviously I can generate palindromes that aren't English words or English phrases, but I think I can ask ChatGPT to help me with that as well. I'm going to copy this, I'm going to head over here and paste it in. I'm going to have to annotate it a bit because I asked that clarification. So it says, ignore spaces and punctuation during the check, treat uppercase and lowercase letters as equivalent. So here's the way I'm going to approach this. What I'm going to do is I'm going to take the string the user gives me. Oh, actually, I'll just do that now. I'll go get the string from the user. So we've already got the logic to get the string from the user. I'll just paste that right in. Enter a string, and then I get the string. And the string, with getLine, it can contain spaces. I get the string from the user, and suppose the user enters something like this. So race car is a palindrome. Let's do this. Race car. Or even better, let's put a space between race and car. So race car. What I'm going to do to decide if it's a palindrome is, first, I'm going to deal with the capitalization, space, and punctuation problem. So I'm going to make a new version of the string where I've converted every character to lowercase, and I've left out all of the spaces. The way I'll do this is I'll iterate through my original string from left to right, take each character, convert it to lowercase. If the character is a space or punctuation mark, then I'm going to just ignore it and keep moving. Otherwise, I'm going to add it to a new string, a new sort of cleaned up string. And actually, I'll need to know what it means by punctuation. There's one way of interpreting this of ignore spaces and punctuation. Maybe what it really wants me to do is just ignore every character that isn't a letter. I'm going to ask it if that's what it means. Now, if it says no, then I will have to do just spaces and punctuation. But if it says yes, I'm going to act based on that. In exercise 2, is it sufficient for me to ignore every non-letter character instead of just ignoring spaces and punctuation? Yes, it's generally sufficient, okay, to ignore every non-letter character, including spaces and punctuation marks. It's trying to, I guess, tell me, don't worry about that, worry about the letters. So I'm going to treat this as gospel. I'm going to say, okay, fine. In that case, I will, whether or not I keep a character will be based on if it's a letter. If it's not a letter, I'm going to throw it away. I'm going to ignore it. All right, so I need to make a cleaned up version of my string. So I'll make a string for that. So I'll call that input clean. And I'm just going to walk through. So I'm going to say for each character C in my original input string. I'm going to walk through my string and I'm going to first ask the question, is C a letter? Now to ask if it's a letter, I need a function from the library. You may recall from your C course that there is a function called isAlpha in the C standard library to test if something is a letter or not, whether it's either uppercase or lowercase. And as it turns out, almost all of the C standard library is available in C++, and that includes the isAlpha function. It takes one character and returns true or false. It is found in a library header called cctype. So for C++ uses of C library things, usually if you, in C it would be ctype.h. What you do is you take off the .h to go to C++ and add a C at the beginning because it's from the C language. So cctype gives me std isAlpha. So I'm going to first ask, is this character a letter? So if std is alpha of C. Now, if so, then I want to add it to my cleaned up string. But first, I want to convert it to lowercase. And I'm going to use for that another function from ctype.h in C, or cctype in C++, toLower. The toLower function takes a single character and returns the lowercase version of it. If the character isn't a lowercase letter, or if the character is an uppercase letter, it converts it to lowercase. If the character is anything else, or if it's already a lowercase letter, it just returns that character intact. So I'll say input clean plus equals, I'm going to add this character to the end of it, the result of calling toLower on my character C. And then before I go further, I'm just going to print out that string. So clean string, and then I'll print out input clean. Okay, so I'll do practice strings 2. Enter a string, let's do, well, okay, I'll do race car. And the clean string is just race car. And that looks like what I want. I may need to do more testing later, but I'm going to keep moving with the exercise and see if I notice any bugs. So, okay, now how do I determine if something's a palindrome? So let's try the word, okay, so level is a palindrome. A word is a palindrome, according to the definition, if it is the same backwards as forwards. In other words, if the reversed version of the string equals the original string. And so the word level, if I create the reversal, oh no, how am I going to do that? If I create the reversal, it's exactly the same, and the strings match. So I think it is a palindrome. If I look at the word lever, then I get this reversal, and these two are not equal, so it's not a palindrome. So actually, my palindrome check is pretty easy once I have my cleaned up string, because I can recycle some code from exercise 1. I just reverse my input string. Because I want to use this, and I may want to use it again later, I'm going to make a function for this. So I'm going to make a function called reverse string. And it takes as input, we'll just call it the string input, because that way, if I call the variable input, I can just paste my code directly in because it uses a string called input. And then I return reversed. Okay, we'll just remove some spacing. I'm not going to test this specifically because I'm pretty sure that it works because I tested the exercise earlier. Now what I'm going to do is I'm going to comment out this print statement, and I'm going to say, let's see, so I'm going to say string reversed, and then I'm going to set that to reverse string of input clean. I reverse the clean version of my input string, and then I have to ask, is the reversed version equal to the original? Now in C, you'd have to use a loop for this, or call a library function. But in C++, another way of showing off the nice convenience of strings, I'm allowed to just ask, is, using the equals operator, is input clean equal to reversed? And that's it. And if the two are equal, then I have a palindrome. And I'll print the string out again. I'll print the original input string is a palindrome. And then what I'll do is I'll just copy this into the else clause for the is not case. And I'll say is not a palindrome. And I'll do a couple of tests, and then I'm going to ask ChatGPT for some more tests. So I'll try level. The answer is yes, good. I'll try lever, and the answer is no, also good. I'll try radar, the answer is yes. I'll try race car, the answer is yes. I'll try, I need to make sure I try a bunch of strings that aren't palindromes. Okay, so that's not a palindrome. I'm going to try mixing capital and lowercase letters. Still seems to work. L-E-V-E-L. I'll now try the string that it provided, so that's a man, a plan, a canal, Panama. Looks like that works. It is a palindrome, so it is able to dispose of all the punctuation and other non-letter characters. Let's see if we can get some other test cases. Can you generate a list of, I don't know, let's do 10 test inputs for exercise 2. Don't show me, oh, actually, don't show me the solution to the exercise. Certainly. Okay, so here's some examples, and it claims that these cover cases that are regular palindromes. I guess it means for that, like all lowercase. Palindromes with mixed capitalization and some non-palindromes. Hopefully I can figure out the difference between them, but I'll just copy them over and head over here. I'm going to put them in a comment just so that I can remember to test them. All right, so we'll try testing at least a few of these cases. So I already did race car and level. Okay, apparently was it a car or a cat I saw. Well, that's clever, I guess. That's a palindrome. Oh, whoops! I put a quotation mark at the end, but the quotation mark gets ignored because it's considered punctuation. So that is a palindrome. Okay, so deified. Looks like that works. I'm going to need at least a couple of examples of things that are not palindromes. I guess the string "not a palindrome" is not a palindrome, and that comes out with the answer no. Okay, so Madam in Eden. I'm Adam. That's interesting. That is a palindrome, and it looks like it is. It doesn't. ChatGPT didn't tell us, but it does seem to check out. What about Ava? Can I see bees in a cave? Where is it? I mean, is it making these up or is it getting these from somewhere? That is a palindrome. Do I buy that? Okay, I guess the middle is this letter B here. So yeah, that's a palindrome if I ignore all the spaces and punctuation. And so I think I've completed exercise 2 as well. And I'm really happy ChatGPT could help me with the inputs because I don't have any interesting, clever ideas of palindromes. So we'll save that. We'll head on over to exercise 3, which as I recall is a bit more challenging. So what's exercise 3? Exercise 3, word count. Build a program that takes a paragraph of text as input and counts the occurrences of each word. Output a list of unique words along with their counts. Now, there's a way of solving this using like next week's material that's going to be a little bit cleaner than what I'm going to do, but there is a way of solving it with this week's material, just with vectors and strings, and so I am going to solve it that way. Let's see, treat uppercase and lowercase letters as equivalent, yep. And disregard punctuation and consider words separated by spaces. What I interpret this to mean is basically that I could, if I wanted to use the regular input, the word-based input, I think I might ask ChatGPT to clarify what it expects me to do as far as input. But I'll head over, grab the exercise, put it over here, do a little bit of formatting. And I notice a couple of things that bring me back to the last exercise. So it says, first, treat uppercase and lowercase letters as equivalent. Disregard punctuation. So I think that when I make up my catalog of words, I'm going to want to do the same cleaning as I was doing in exercise 2. So I'm going to actually bring in the cleaning code from exercise 2. That would be this. Okay, so I'm just going to bring this. I'm going to actually, maybe I'll copy in the whole thing. The other question is, how do I read a paragraph? Now, there are a few ways to interpret this. So one of them is, often when you enter a paragraph, you're actually just, if you're typing in Microsoft Word and you're writing a paragraph, you don't press enter. You just keep typing and, it automatically moves characters between lines. I could interpret it like that. So the only new line in this paragraph is the one at the very end. So I could just tell the user, enter a paragraph, don't press enter. And then, until they get to the very end of the paragraph, they don't press enter. So the whole paragraph ends up as one long string. I think that's the way I'm going to start by interpreting it. And I guess I could do that, read it with getLine, and then pull out every individual word. I could also read words individually using this notation here. Now, as far as doing the exercise, this is probably easier because this gives me the words right off the bat. It doesn't require me to go through and strip out all the spaces. So I'm going to ask ChatGPT if this will be sufficient to read a paragraph. I'm actually going to give it a little bit of code to play with and see if it likes it. So I'm going to say, I'm going to make a string called word, and I'm going to say while I'm able to read a word. Remember that when you read strings using this notation, you have to enter Control-D to signal that you're done entering your input. I'm going to put all the words in a vector of all of my words. So include vector. And then I'll say, and I have to actually create a vector somewhere. So I'll say vector std string. I'm gonna actually put every word that I read into a big vector. We'll call it all words, so it's clear that it's a big vector. Then I'll do all words dot push back word, and I'm gonna actually ask ChatGPT if this is sufficient to read a paragraph. And if it says yes, then I'm going to do it. If it says no, then I'm going to work around that. I'm working on exercise 3. Here is the code I've written to read a paragraph and store each word in a vector. I haven't gotten around to ignoring punctuation or case sensitivity yet. Is this the right way to read a paragraph in this exercise? And if it says yes, then I guess the answer is yes. Oh, I should have said don't show me the solution. If it shows me the solution, I just won't scroll. Nope, don't do it. Your approach is close, but using cin has some limitations. The code you provided will work fine for reading individual words, but it might not handle spaces in new lines. That's sort of weird. So you said I shouldn't use cin because of spaces and new lines, but you also said earlier that I should ignore spaces and new lines, so other types of white space, when counting words. What gives? I'm going to scroll past its suggested code. I apologize for confusion. You're absolutely right. So I'm going to admit that I'm sort of manipulating it a little bit here. So to be clear, if it tells me I'm allowed to do it, I'm going to do it. But I've learned already that with ChatGPT, it appears to be very impressionable. If you ask it the right kind of leading question, it almost always agrees with you. So here I've pointed out what I'm sort of maybe implying is a mistake. And it looks like no matter whether it's made a mistake or not, it says, I'm sorry, and then tries to fix it. And so yes, I actually admit that I sort of knew it would do this. I appreciate your attention to detail. Okay, so now it's saying, in the context of exercise 3, using cin in the way you described is appropriate. The reason that you're interested in individual words in their count, and then this, whatever, okay. So I'm going to interpret this as saying, yes, you are allowed to use this code. It looks like this is just my code again, but this is, I guess, a proof that it does seem to think that the code I wrote is sufficient. I apologize for any confusion. No, don't apologize, and also don't be such a pushover. So if you have a question about the exercise, whether it's ChatGPT's exercise or mine, feel free to ask for a clarification. I think I'm probably less of a pushover than ChatGPT, but we'll see about that. So I interpret this to mean that what I just wrote is sufficient to enter a paragraph. I will tell the user, press Control D on a blank line when done. So as we know, when you're reading words with this notation, you have to press Control D on a blank line to signal that you're done reading input. All right, now how am I going to do this? So what I'm going to do is I'm going to put this code in a comment. I want to just show off what I've ended up reading. So I'm going to say, I'm going to print out all the words. So here are all of the words. And then I'll just print them all out one per line. So I'll say for every string, string S in my vector all words. How is that going to work? Well, we'll print out the word. We'll then print out a new line. I'm going to ask ChatGPT for GPT for a sample input here. Did it give me a sample input for exercise 3? I don't think it did. So I'm going to say, can you give, let's ask it for 5 or 3. The 5 is good. Can you give 5 sample inputs and the expected outputs for exercise 3? Don't show me the solution to the exercise. I should get a hotkey that types that in. Oh, I forgot to put a question mark, but I think it'll understand. This is a sample paragraph. It contains several words. So I noticed that I don't see any words that appear twice. And so the expected output is this is a sample paragraph. It contains several words. That doesn't make any sense. But okay, we'll keep going. Programming is fun. C++ programming is more fun. So here the word is appears twice. Wasn't the exercise to count the words? I don't think it remembers what the exercise was. Wasn't exercise 3 about counting words? You're absolutely right, and I apologize. Yeah, I don't really feel bad about correcting it here because it isn't paying enough attention. Okay, it looks like it's completely forgotten exercise 3. So I'm going to scroll all the way up. As far as I remember, the point of exercise 3 is to count the list of unique words and their respective counts. You said that in exercise 3, I should, and I'll just quote it back to itself, output a list of unique words along with their respective counts. Your output does not meet that criteria. I'll be professional about it, but I'm disappointed. It's going to apologize. Yeah, there it goes again. You're absolutely right. I don't think I'm always absolutely right, but I think I do have a point here. Okay, so now maybe it worked. Here is a paragraph that doesn't have duplicate words, and we can see it prints out each word. It doesn't seem to ignore punctuation. Oh my, what? Okay, in this case, the word is appears twice. Notice how in the output, the word is showing up with a count of 2. So it's slowly getting the idea. Hello there, how are you today? Okay, this isn't ignoring punctuation. Here, the word fish occurs 4 times. And yeah, 1, 2, red and blue. To be or not to be. Okay, and so the word be occurs twice. Okay, this is interesting. So it looks like it is able to ignore punctuation when it does the counting, because it doesn't include the comma when it does when it counts the word be. And yet, for some reason, in the other outputs, it includes punctuation. I'm going to give it a hard time because it's getting a bit annoying. You've added. I'd spell the word you've added punctuation to the output. But wasn't I supposed to ignore that? So I mentioned in the last video that there are people out there in the world freaking out about how ChatGPT is going to take all of our jobs, and yet here it has failed at a basic comprehension question, and it's even more embarrassing because the thing it wasn't able to understand was an exercise that it generated itself. It can't even understand things that it came up with. It looks like it's now fixed it, so I think these are our canonical test inputs. Now that said, I've noticed once you begin arguing with it, it often goes way off the rails. So if it generates something incorrect, even if you argue with it, you should be very careful not to trust what it produces, because as you saw, it made a whole ton of different, like a cascading sequence of different errors. But I have enough now to understand the exercise. Oh, no, I don't. The word this is only there once, and it counts it as twice. Okay, I think we get the general idea. We're not going to trust the expected output. What I want to do is, let's do... I saw one that worked pretty well. Yeah. Okay. So here, the words are 1 fish, 2 fish, red fish, blue fish. One of the words occurs 4 times, the rest occur once. Notice how I don't print out the word fish more than once. I just print out that it has a count of 4. So there are a few ways we can tackle this. One thing we could do is we could keep a vector of the count of each word, but then it might be difficult to associate the word with its count. On the other hand, if I have a vector of all of the words, it's pretty easy to count how many times a particular word occurs, as long as I make sure to get rid of the punctuation before I put it in the vector. So that's my next task. The way I'm going to handle this is basically if I get the 2 words hello and then a comma and then the word world and then a dot, what I'm going to do is before I add them to my all words vector, I'm going to first convert them to lowercase, and then I'm going to strip off all the punctuation. So I'm going to do something very similar to what I did in exercise 2. I'm going to create the clean version of the string. And so I'll just copy this code I already brought in. I'm choosing to do that before I put the string in the vector of all words. I'm going to do it here. And so I'll do for each character C in the word. And then I push into all words the clean version of the string, with all the punctuation removed and the lowercase letters and the uppercase letters converted to lowercase. Before I go further, I'm going to test out that that's actually what happened. So I'm going to compile this, which I don't think I've compiled yet, so I really should get around to that. Practice strings 3.cpp, looks like it compiled. I'm going to run it. Okay, enter a paragraph, press Control D on a blank line. So hello, comma, world, period. I don't know, there's that. There's the word hello again. I enter Control D on a blank line, and we can see here all the words. Hello, all lowercase, no punctuation. World, no punctuation. There's the lowercase hello again. So it looks like I was successful in cleaning up the word before I add it to my vector. Okay, so now what I'm going to do is, I've got this vector that contains, I'll sketch this, but I've got 1 fish, 2 fish, and then red. Okay, that's all I need. What I'm going to do now is I'm going to make a second vector that contains only 1 occurrence of each word. I'm going to loop through my big vector, and as I see each word, I'm going to search for my word in the smaller vector. If I find it, then I do nothing. If I don't find it, then I'm going to add it to the end. And when I'm done, that means, so I'll add 1 fish, 2. When I see the second occurrence of the word fish, I search my small vector, but I do find it, so I do nothing else. I don't add the word. That way, when I'm done, the small vector contains exactly 1 occurrence of each word. Okay, so I'm going to call that unique words. I'll make a new vector element type string called unique words. And then what I'll do is I'm going to iterate over all of the words in the original vector, so I'll call it word in all words. I'm going to search for that in unique words, and I'm going to keep track of whether it was found or not. If it was, and actually I'm going to do this with a Boolean variable. So recall, if you haven't seen this already, a Boolean variable is a variable that can contain two different values, true and false. I'm going to assume that the word wasn't found. And then I'm going to go searching in the vector, in my large vector, my small vector, unique words, to see if it's already there. So I'll say for, I'll call it u in unique words. If u is the word I'm looking for, so if my word u is equal to word, then I've already found it. So I set found to be true. If I get to the end of the loop and I still have not found the thing I was looking for, so if not found, so, or you could write if found equals false, either's fine, but I like not found. So I read this is the logical not operator. I read that as not. So if not found, well then the word isn't already in the unique words vector, so I'm going to add it. So I'll say unique words dot push back word. And then I get down here to the end of this. I should now have all of my unique words. I'm going to repurpose this debugging loop to print out the unique words. Here are the unique words. And then I'll iterate over the unique words vector to print those out. And we're almost done, because once I have the unique words, I just print out each unique word along with a count of how many times it occurs in my larger vector of all of the words. Okay, so I'll try running this just to do a quick test. So hello world, hello world, hello, ASDF, hello again. And I press Control D on a blank line, and we can see the unique words are hello world and ASDF. So each word appears only once. I think I'm ready to begin generating the real output. So the real output should say word, colon, and then the word itself, and then a dash, and then count, and then the number of times the word occurs. I am going to make one modification, and I feel like I'm entitled to do this because ChatGPT can't get its act together. It can't even count the words itself. I think I should be allowed to make a couple of small modifications. I'm going to put square brackets around the word. That way it's easier to see what the word actually is. Word. And then I put an opening square bracket, then I push the word itself. I'm going to call it word though, not S. So call that word. And then I'll print the closing square bracket, and then a dash, and then count, colon, and then I print out the count, which I don't have yet. I'm going to work on that in a minute. And so I print out the word, I print out the count. Okay, now how do I do the count? Well, what I'm going to do is, I've got a word from one of my unique words. I'm going to iterate over the list of all of the words and then just see how many match up with the unique word that I'm working with. So my count is equal to 0. I then iterate over, this time I am going to call the string S in all words. And if S is equal to the word I'm looking for, then I increment the count. I've seen one more occurrence of it, count plus plus. And I think that's the end. I think I may have everything I need. We'll compile it. It does compile. Let's enter hello world, hello ASDF, hello world. So I should see 3 hellos, 2 worlds, and 1 ASDF. So Control D on a blank line, 3 hellos, 2 worlds, 1 ASDF. Now we'll try it on some of the sample inputs that ChatGPT provided. So I'm not going to care too much about the sample output because it looks like it couldn't figure that out itself, but I can at least copy these sample inputs. So here it looks like every word occurs once. This thing where this occurs twice seems to be erroneous, so we'll ignore that. So I paste this in, I press Control D, and it says this is a simple paragraph. It contains several words. Everything has a count of 1. I'll just make my output window a little bit bigger here. Okay, let's try the next one. I want one that has at least 1 duplicate word, so it looks like, okay, programming is fun. C++ programming is even more fun. Well, I mean, I agree with that, but it just sounds a little bit insincere the way it's phrased there, but okay. So I'll run this, I'll paste it in, Control D, and we can see the word programming occurs 2 times, the word is occurs 2 times, the word fun occurs 2 times, everything else occurs only once. Now, I guess the word that I printed, so the 2 pluses are counted as punctuation, so I should be ignoring them. That's so I think my output is correct. I don't think this is correct. I think, as I've mentioned, I don't know that we trust ChatGPT's output at this point. I guess we should try this input since I was already experimenting with it. Okay. There we go. So the word fish occurs 4 times. Everything else occurs once. We're well on our way to having this working. Let's see. There's a line from Hamlet, I guess. I guess that's worth testing. And then that's the last one ChatGPT has. I got a couple of my own as well. All right, so we'll paste it in, do Control D. Okay, the word to occurs twice. That looks good. The word be occurs twice. The word, didn't ChatGPT say something else occurred twice? So oh no, that's good. Okay, yeah, so this actually even matches ChatGPT's output, even though ChatGPT is not trustworthy. I want to try out the case where the same word appears over and over. There's only one unique word and it appears tons of times. And then I do Control D. It looks like that worked. I actually can't think of any other test cases. We've already tried capital letters, tried punctuation, tried spacing, maybe one more. Like what if I have lots of spaces, but I don't see a problem with that because the input isn't being read by my code directly. Yeah, it looks like that works too. So I think I've now finished exercise number 3. I really liked exercise 3. So notwithstanding ChatGPT's inability to understand itself, I think that was a great exercise. I don't know that I would have thought of that one myself at this point in the course. I have given this as an exam question later in the course because it becomes much easier when you know other things. But I think it's a great exercise. I also think that disregarding punctuation was a good idea. I think it added a nice extra sort of depth to the exercise. It's too bad ChatGPT got so upset, but whatever. That's one more reason you should feel secure in that getting that engineering degree is worth it, because I don't think you're going to lose your job to ChatGPT.